Okay, guys, so we're going to do this next one. And we do have enough information under our belt to pick up some points on parts A and B. And by the end of the year, we'll know, we'll have some information to pick up points on C as well. So a cylindrical barrel with a diameter of 2 feet contains collected rainwater as shown in the figure above. The water drains out through a valve, which is not shown, at the bottom of the barrel. The rate of change of the height of the water in the barrel with respect to time is modeled by this, where h is measured in feet and t is measured in seconds. The volume of a cylinder with radius r and height h is that. Okay. Now part A says, find the rate of change of the volume of the water in the barrel with respect to time when the height of the water is 4 feet, and then indicate units of measure. All right, so that's part A. And then part B, when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time, increasing or decreasing. Explain your reasoning. So we're going to do both of these. So part A, find the rate of change of the volume of the water. Guys, there's actually two ways of approaching this. I guess I'll just approach it this way, okay? So, all right, so this is for part A. All right, let's think about what we know. What do we know? We know that the radius, so when you're thinking about what you know, this we're talking about in terms of, so we're going to have to take the derivative of this equation here. What do you know about V or its derivative? What do you know about R or its derivative? What do you know about H or its derivative? Okay, so what do we know? We know actually that R is 1. Okay, we know that R is 1 because the radius of this cylinder is never changing. Okay, and we're given that the diameter is 2 feet. So, so this radius is 1 always. It's constant. Okay, so we know that the radius is 1, and we know that that is a constant. When you're doing these types of problems, guys, it's important to pay attention to things that are constant because the derivative of a constant is 0. Okay, so guys, we can also say that R prime is 0 because R is constant. Okay, find the rate of change of the volume of the water in the barrel with respect to time when the height of the water is 4 feet. So we also know that the height is 4, but not always. Okay, this height is not always 4. And we also know that H prime is equal to -1/10 radical H, which at this moment is 4. So this is -2/10. That's -1/5. Okay, so these are the things that we either know or can surmise from the information that they gave us. All right, now what do we want? We want V prime. Okay, so I'm going to take V equals pi r squared h, and I'm going to take its derivative. So V prime equals 2 pi r prime h plus pi r squared h prime. Okay, then I'm going to plug in this stuff. So this is 2 pi 1/0 plus pi 1 squared h prime is -1/5. That whole thing is 0. So V prime is negative pi/5. Okay, just multiply that. We need units. Indicate units of measure. They're telling you that. So volume is cubic units, guys. So this is going to be feet cubed per minute, I think. No, seconds. Okay, so that is part A. Now, part B. This is a little bit tricky. When the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Is the rate of change of the height of the water with respect to time, I guess? All right, I was going to stop at water, but they're asking if this is increasing or decreasing. Is the rate of change of the height of the water increasing or decreasing? Guys, what is the rate of change of the height of the water with respect to time? Guys, that's dH dt. They are, okay, or you could say H prime. They are asking, they're not asking if H is increasing or decreasing, which is actually kind of like what my brain thought at the very beginning. My brain thought, oh, they're just asking if this rate of change is positive or negative, because that would indicate whether H is increasing or decreasing. No, they're asking, is H prime increasing or decreasing? So guys, you need to be thinking of Susan's table. So if you have H, H prime, H double prime, think of the Susan's table. We're being asked, is H prime increasing or decreasing? Well, that would correspond to H being concave up or concave down, and H double prime being positive or negative. Guys, this is what we care about. This is the part of Susan's table that we care about. So we need to take, we've already got H prime right here, all right? We need to find H double prime. So I know, I'm just gonna use prime notation, guys, because, oh, what am I doing? -1/10, and then that's H to the 1/2. I can use prime notation just because it's less writing. So if I want to take the second derivative, this 1/2, so this is going to be -1/10. The 1/2 comes down, H to the -1/2, H prime. Okay, because we're doing dH dt, so we need chain rule on it. All right, so the H prime is the chain rule part. H is actually H of t. Okay. But then, guys, what is H prime? H prime is this. Okay, so that goes back in there. So it's H double prime equals -1/20, right? H to the -1/2, and then in for H prime goes -1/10 radical H. Okay. And guys, this H to the -1/2, that actually could go on the bottom. That's -1/20 radical H. And then that's, this radical H is actually like on top. So you could even express that as negative radical H over 10 if you wanted. Okay, now we want H double prime when H is 3. Okay, so you could go ahead and just plug H in if you want. 3 for H, but it actually turns out that these are going to cancel no matter what. You've got a radical H on the bottom and a radical H on the top. Those are going to cancel no matter what. Feel free to plug 3 in for them. But it turns out that this ends up that H double prime ends up being 1 over 200 regardless of what H is, because those radical H's cancel. So I'm just gonna say, like, off to the side, so is the rate of change of the height of the water, so is H prime increasing or decreasing? Explain your reasoning. So over here, and in the notes, guys, I wrote this a lot nicer. All right, I'll just say it like this. I'll just say at H equals 3, H double prime equals 1 over 200, and then I'll be like, is greater than 0. Therefore, H prime is increasing. Yeah. Okay. So just like that. All right, guys.